Okay, as a summary, on semester 1, the main objectives and achievements of task 4.3 were the development of the initial backplane API framework, let's say, mainly on the backplane API gateway developed on the main stage with WP4, and also with first OpenID Connect authentication middleware, just integrated with, let's say, a dummy keycloak OpenID Connect provider, and also providing internal JSON Web Token authentications with internal communication between services and the backplane API. Also, we had started the design and the implementation of the Service Integration Manager tool. That is a tool that will help into the automation of the process of the integration new services following the OpenAPI specification. So on the semester 2, the backplane API was upgraded to use the OpenID Connect provider developed on the task 3.1, and also added the authentication scopes to enable a restriction on the authentication to services. Okay. Also, the communication with the subsystem was secure with certificates, and also the Service Integration Manager was upgraded just to include those authentication upgrades put also on the backplane API, so are in harmony both backplane API and Service Integration Manager tool. Okay. Also, we created several service templates in order to make life easier to all the partners to develop the services that will be integrated inside the backplane API. So we provided the templates that were fully compatible with the state of the backplane API on every stage. And last one, on the semester 3, the objective were to integrate as many services as possible. So we upgraded the service integration tool to simplify a little bit the process of specifying scopes, and also we deployed on the project infrastructure all the backplane API on all nodes and automate all the deployment process to be, let's say, DevOps-like. Okay. We have integrated the auditable accounting, the semantics, and the data storage, as well of the user-centric authentication for the authentication of the backplane API requests. And also, we have started the creation of a specific web portal for developers to include all the documentation or guidelines regarding to how to integrate services or how to contribute to the all services that will be or are inside the backplane API. So let's Victor will explain to you the automatic process of deployment.
Okay, as Juan just said, the deployment process of the backplane has been automatized. To keep things as agile as possible, I just make a few 5 cents. In short, this deployment process builds a new backplane instance, taking every OpenAPI specification of subsystems that is available. The subsystem, these OpenAPI specifications are located in a repository for that purpose only, and any change in that repository will trigger a new backplane deployment. This deployment is handled by GitLab CI that just gets all the OpenAPI specifications, builds the code necessary to integrate the subsystems with the backplane, builds the Docker images, and deploys them with using an Ansible playbook. Now,
yes, just a global overview. The list of achievements and their impact are these ones. Okay, the main objective is the backplane API itself, the Service Integration Manager with the integration with the backplane API, to integrate the services using that tool inside the backplane API and be deployed, and also to provide those commented backplane API specification for developers. Okay. So let's pass to the demo.
Okay, the demo will be in two parts. First, I will do a brief introduction of the current state of the backplane, and then we'll do a joint demonstration of the integration between the backplane and a subsystem, in particular the auditable accounting. And we will, with the help of Rafa, we will do the demo of the auditable accounting using accessing every endpoint of the subservice through the backplane. In short, you can see here it's the backplane OpenAPI specification. As you can see, it has many endpoints that corresponds to different subsystems. As you can see, the endpoints that belong to a subsystem have a prefix that matches with the subsystem, thus avoiding any possible clash of endpoints between different systems. These endpoints correspond to as I said before, the different OpenAPI specifications available in the repository. Now, there are only 4 OpenAPI specifications available. One of the Gritter service, that is a dummy service made by us to test it, and 3 of the actual deployed E3 Market systems. So now, with Rafa, if you are, you can start. We will do the. Oh well, just a brief. Every time you'll see I make a request is done to the auditable accounting, you will see a log on the terminal pane on the right, showing that the redirection. For example, if I make a request to get the registries count, you can see that the request, the backplane has received the request. It has redirected it to the auditable accounting instance, which is located in the node 1 at port 8090, and then has sent the response that we can see here. So with that, Rafa, you can. I'll try to keep up with you making the request as you explain everything.
Yes, thank you, Victor. Well, I'm Rafa, also from the UPC, and we work on the auditable accounting module. And yes, the developments of the past month were to develop this part in the DevOps-like deployment and integrated with the backplane. And as Victor said, the idea is to manage this component over this API, the backplane. And just to remember, the auditable accounting, it allows the platform to store registries of data. In that case, if anyone wants to keep some data, some value, it needs to make a new registry with the hash of that value, and the idea is to keep that on blockchain. But the problem is, depending of the number of registries made on time, it could be difficult to manage that on chain. To optimize that, we prepare in the auditable accounting component Merkle hash tree to merge all the hashes from a certain time, for example, every hour, every day, or every minute, and to prepare that and store only on the blockchain the root of the current Merkle tree. Then the idea for the demo is just to register some new hashes or data in general. We have not check that right now. Then the idea is to do, the first thing is to post an auditable accounting registries. Yes. And to try it out, you have to insert here the hash. As shown, you can include the hash at this point is string or change for something, yes. And the result, you can see the ID of that hash and the value. For example, let's add another to allow the new branch of the tree. And as you can see, here's the other. The idea is At this point, we can go directly to the blockchain controller, but now as this API enables you to check some, for example, so the number, the count of current registries from the past, or at least the number of registries recorded since the startup. In this case, is 9, and we can also get some specific ID, making a get exactly that one, and for example, take the last one, the number 9 or 8, it's okay, and we can check this is the another, and the ID number 8 is the first one we recorded in this demo. Now at this point, we are ready to prepare to update the Merkle hash tree and upload the root to the blockchain. In that case, we can get the current root from this contract. That we can check that there it is, that it starts with 0FF. That's the actual root we made making previous checks. But now we can compute the new Merkle root from these new registries. That is just executing this endpoint. Yes, exactly. And that's it. The result is okay. The new Merkle root is that number, A21, and the transaction that we will send to the blockchain is prepared, and that it has this hash. And now we prepare. At this point, we don't send any transaction to the blockchain. Instead, we only compute it and store it on our database. But because we can make a cron or some scheduled task to send the transaction only in a certain time to manage only to optimize this transaction. And when at this point we are able to update the registries and executing this endpoint, it will generate the transaction over the blockchain. And I don't know, Victor, if you have the link. Exactly. We prepare the blockchain, the Besos, and also we prepare that is generated a new block each 60 seconds, every minute. And at this point, this block is newly generated, and we can see here the details of the block, and also we can see that there's only one transaction from the account to the smart contract. That shows that this new root is also included. At this point, this Explorer don't have the capabilities to show the input data converted into the function called, but from the API, we can also call again the get Merkle root, and see that it's modified and share is the new A21 root. And that's more or less all the demo from the Auditable accounting. I don't know if you, Victor, want to add something about the backplane.
No, I think that's also all for us. Since we have shown, I think, perfectly that the interaction with between backplane and the Auditable accounting service subsystem in this case works quite smoothly.
Cool. Then just to finish the Auditable accounting, the idea, the future developments about that, maybe we should migrate the Postgres SQL database, which is centralized, to integrate it with the decentralized storage to avoid this centric point of failure. And more or less, it's that all the developments needed for this component. If you have any questions or suggest.
If not, is all from our part.